Okay, last but not least, the graph of a radical function, and we will have studied 4 different types at this point. So a radical function is a function where the independent variable x is under a radical that has an even index. So we're just going to look at square roots, to be honest. So this is the index right here, so square root. Um, in these cases, you'll be sure to choose values for x that keep the expression under the radical positive. Because right now we do not know how to take the square root of negative numbers. Not yet, anyway. So we have to pick values for the domain of these functions that will work so that we don't have to evaluate the expression for x to be negative. So you see this positive 4? If I used a negative 4 for x and added 4 to it, I'd get 0. And the square root of 0 is 0. Well, that's all fine. Now what I have to decide is if the next number I should use is a negative 5 or should I use a negative 3? I just need to use a number on either side. Would you notice this? If I used a negative 5 under the radical for x, a negative 5 plus 4 is a negative 1. And I don't know how to take square roots of negative numbers. So I'm not going to do that. I'm going to use a negative 3 under the radical because when I add 4 to that, I get the square root of a positive 1. The square root of 1 is 1. Now, I do have to be careful when I pick my values, especially with radical functions. If I use a negative 2 next, a negative 2 plus 4 is the square root of 2. And the square root of 2 is 1.414, and that's a hassle. So the next number that I'm going to pick for x is going to be a 0. Because when I put a 0 under here, I'm going to have a perfect square under the radical. In other words, I can take the square root of it. 0 plus 4 is 4. That's how I picked 0, because I knew the square root of 4 was 2. The next number I'd like to put here, right there, is a number that will cause this to be 9, because the square root of 9 is 3. So if I put in a value for x of 5, right here, then 5 plus 4 would be 9, and the square root of 9 is 3. The next perfect square is 16, because the square root of 16 is 4. So I would need to put a 12 in here for x in order to add 4 to it, get 16, and then the square root of 16 is that 4. Let's go ahead and graph this. So I go to the left 4, and don't go anywhere in the y direction, a negative 4 comma 0. Then I go to the left 3 and I go up 1. Well, I can try this one, negative 2 and up 1.4. But I like to tend to stick with these whole digits. So when x is 0, y is 2. When x is 5, y is 3. And when x is somewhere way over here, 12, y is 4. The graph of this radical function starts right here. I work left to right and connect these with curved dots, and it just goes on into infinity. Both for x, this just keeps going, and it keeps getting higher too in terms of y. So let's talk about the domain of this function. The domain of this function looks to be all real values for x, where x has to be bigger or equal to the number a negative 4. See right here? X was a negative 4. That worked. Negative 3 worked. See these right here? Those values worked. 0 worked for x. 5 worked. 12 worked for x. The range of this function is also all real numbers, but the y values also are limited to being above this line right here. The y values are all above here. So what's the y value right here for this ordered pair? Let's see, negative 4 comma 0. So the y values appear to need to be greater than or equal to 0. Let's just check this on the graphing calculator. Let's see if I can. I'm just going to put it in right here. So we have the square root of x plus 4. We'll close the parentheses. And you know I started at a negative 4 here for x. I'm going to start my table at a negative 6. And I'm going to go in increments of 1. And then I'm going to go second graph. And I just want you to see these errors that occurred. When I tried to use a negative 6 and a negative 5 in this equation, they just didn't work. But negative 4, no problem. Negative 3, no problem. 0, and I could, go on down. Also, can you notice that in the y column, it's showing us that the y values are all greater than 0. So that's pretty cool for a radical function. Let's go take a look at this one. So let's go ahead and just put it in the graphing calculator. So we have y equals the square root of 3 minus x. So let's graph it and see how that curve goes and what its limitations are. So do you see this spot right here? That's where x is equal to 3. It looks to me like x could be 3 and 2 and 1 and 0 and a negative 1 and a negative 2 and a negative 3 from the picture. Again, looks like x could be 3 and less from this picture. Let's go ahead and check the table. We thought x could be 3 and less. So let's start it at a negative 2 and see what happens when it gets up to 3. So 3 is okay, but 4, there was an error. In case you hear some background noise, there's some police training going on in the building, and so I've got a little bit of loud sounds going on. Hopefully you're not hearing it. So again, x could be 3, 2, 1, 0. It can't be 4, because when I try to put a 4 in here, for x, I get a negative 1 under the radical, and right now I don't know how to deal with that. So let's go ahead and create our table of values for this. Again, you can just do it from your graphing calculator. But what we did from that is we determined that we could use a 3 and a 2 and a 1 and a 0 and a negative 1. We just couldn't use a 4. So if I did this by hand now, when I put a 3 in here, 3 minus 3 is 0. Square root of 0 is 0. 3 minus 2 is the next value, is 1. Square root of 1 is 1. Now I'm inclined now to not bother with putting a 1 in here because that'd be the square root of 2. What I'm really wanting next is for a 4 to come out here. So the only way to get a 4 is to put in a negative 1 for x. So 3 take away a negative 1 means 3 plus 1, which is 4. And the square root of 4 is 2. The next one I'd be shooting for is to get a 9 in here because the square root of 9 is 3. I would have to put a negative 6 right here because 3 take away a negative 6 is 9 and the square root of 9 is 3. I'm sorry, I put in a negative 6 here. All right, so let's go ahead and graph these. X is 3, y is 0. X is 2, y is 1. X is 1, y is 1.414. Not going to bother with this one. When x is a negative 1, y is 2. When x is a negative 6, so 2, 3, 4, 5, 6, y is 3. And the picture is worth a million words in that it describes that the domain of this function has to be anything to the left of 3. So the domain of this function is all real numbers where x has to be less than or equal to the number 3. The range, which is the y values, can be all real numbers, but the y values again are greater than or equal to 0. They're above the x-axis. They do equal 0 right here, but all these y values are above and they go on out this way. We're going to come back in our last segment and we're going to do some graphing of real applications and be finished finally with the graphs of functions.